So I forgot to start recording at the very beginning, but what we discussed was, yesterday we defined the square root of negative 1 as I. So I did the first, is just I. So I squared would be where we square what I equals, which is the square root of negative 1. So the square and the square root cancel, so I squared is negative 1. I cubed could be rewritten as I squared times I. Well, I squared simplifies to negative 1, so negative 1 times I is negative I. I to the fourth is I squared times I squared, which is negative 1 times negative 1, which is 1. Okay, you guys take a minute, and I want you to find I to the fifth, I to the sixth, I to the seventh, I to the eighth, I to the ninth, I to the 10th.
I don't think I'm quick to do that.
A minute is more than enough time.
Is it a pattern?
I don't think I'm equipped to do this. I still don't get it. Oh, I think I get it. Good job, thanks for teaching me. Let me tell you in a minute, okay? My eyes? Yours are weird too. At all. You go like, popsicle.
Can you explain to me the process of I squared?
There's like my eyes.
Okay, since I is the square root of negative 1, I squared, I could substitute square root of negative 1 in where the I was.
Okay, I see.
That's what I did. And then the square and the square root are going to cancel. So we get negative 1.
Okay, thank you.
Shut up. Did you get that 5? You get negative 1.
And you just remember the beginning of the board.
Why? I think it is, dude. That's the only thing I can do.
Yeah, it is pattern.
Yeah, it's gotta be. If it's not, then I really have lost.
I told you.
I did the third. Negative I.
Yeah, negative I.
I'm gonna erase my paper. How do you know?
Okay, so I to the fifth, did y'all rewrite that as I to the fourth times I? Which is 1 times I or I?
Wait, I got I.
Okay, did anybody do I to the fourth times I squared here? So 1 times negative 1 is negative 1. I to the fourth times I to the third. So it's 1 times negative I is negative I. I to the fourth times I to the fourth. 1 times 1 is 1. Who sees the pattern? I, negative 1, negative I, 1. I, negative 1, negative I, 1. I, negative 1, negative I, 1.
Why is it such?
It keeps repeating, doesn't it?
Yes.
Forever.
Why is it the 4 different things that keep repeating?
They just do.
Because for powers of I, this is where you start seeing it repeating. We do the same thing on math team when we raise a number to a power and we're just looking at the units digit, the ones place. It starts repeating every time when you do powers. And so you can find the units digit or you can simplify I to any power by looking at how many times it goes through this pattern completely and then how many are left over. Because the leftover part is where it lies in the pattern. Okay.
So it would be that one.
So I to the 101st
That would be I.
is the same as I to the first, which is I. I to the 83rd goes through this pattern completely 20 times, doesn't it? Because it repeats every 4. So 83 divided by 4 goes in there completely 20 times. And what's left over? 3. So what does I to the third simplify to? Negative I. Okay? I to the 400th.
One.
It goes through the pattern completely 100 times. Well, if we're through the pattern completely, where are we? We are at the bottom. 1. Okay, I to the 97.
Wait, it'd be 1, not I?
That'd be -1. Or no, that'd be
It'd be
I.
that'd be I. That'd be I.
Okay, so
No,
you
it'd
need to
be
do it old
-1.
school, do it old school. So,
-1.
okay, goes in there. All right, I'm good. 17, 4, I'm good. My remainder is 1, so that's the same as I to the first, which is I.
Oh.
Okay, if it's 24, which one are you connecting it to?
This means it goes through the pattern completely 24 times.
So how do you find which one out of the one?
And then there's 1 left over. The remainder part is where it is in the pattern.
So 1,
So
2,
if there's a
3, 4.
1 left over, then it goes back to this first one. If there's 2 left over, it would go back down to the second one. If there's 3 left over, it would go here. But if there's nothing left over, that means it went completely through the pattern and ends here.
What if there's 5 left over or more?
You didn't divide correctly because you're dividing by 4. So if you get
Oh,
a
yeah.
number
Okay.
bigger than 4 or larger, then we had a
Then you would
division
just divide through a whole nother
glitch.
Wait, you would never have a remainder of 4 though, would you?
Nope. This would be, you could kind of think of this as no remainder. So like I to the 0. And anything to the 0 power is 1. Okay? Alright, so those are our powers of I. So I could ask you to do I to any power I felt like. And then you can do simple division by 4 without a calculator.
Will you not do it into the thousands?
I'm making no promises on that. Okay.
I'm really bad at thousand division.
We need to know things like this to be able to do our multiplication and our division. So let's say we had this imaginary number, 2i, and we're going to multiply it times this complex number, 3 minus I. So what do you think we do?
Distribute.
Distribute.
6i.
And so we get 6i minus 2i squared.
Second.
So negative
And
2.
what is the value of I squared?
6 equals 2.
Okay, so since I squared has a value, I tried to change
Negative
colors.
1.
Come on now.
-1.
I squared is like multiplying by -1. What's it going to do to that sign?
-2 times -1.
Yeah, it's going to make it positive 2. Okay, is that the correct way to write my answer?
No, you
No.
have to do 2 plus 6i.
2 plus 6i.
Do we need to memorize these 4 patterns?
Yes. Okay, so let's say we have 5 minus I times 2 plus 4i.
I hate these ones where you have to multiply like all of them.
These are okay.
It's my like least favorite part of math. Actually, that's not true. Probability.
Probability.
That sounded weird. Probability.
You do know that this multiplying 2 binomials used to be in 8th grade.
Well, I'm not saying it's like hard. It's just time consuming and confusing. I mean, not really.
Distribute the 5. No, not really. 10 plus 20i. Distribute the negative I. Negative 2i minus 4i squared.
Are we gonna ever have to do the conjugates?
Yeah, we do conjugates with this too. Okay, but the 4i squared, this I squared is like multiplying by -1, and when we multiply by -1, what does it do?
Make sure
Change
we
the
change
sign.
signs.
So it becomes plus 18i plus 4. So my answer is 14 plus 18i. Okay. Anytime I multiply by -1, what does it do? Change the
Change the
sign.
signs.
So what I end up start doing, once I realize that I squared is just like multiplying by -1, I just go zoop, zoop. Because multiplying by -1 just changes the sign, right? And then it saves me a little
Wait,
writing.
is it just that sign?
Yep, because that's the only thing multiplied by I squared.
Oh.
So that's the only sign that changes.
Okay.
Okay, 3 minus 5i, quantity squared. You try.
I mean, I could just do things that are accepted.
Will we do this like the pyramid thing?
Yes, I would. Right, but you just write it as I.
Yeah, I think I did this right. Did you? Pyramid thing.
Okay, so some of you may have written it out twice
Why?
and got 9 minus 15i minus 15i plus 25i squared. And then you said, okay, change, change. So this made negative 16 plus, minus 30i.
And negative 16.
Okay, if you thought of the Pascal's triangle, you square the first one, 9. That middle term was a 2. So you double the product of these two. The product is 15. I double that, I get 30i. And then we square the last one. When I square negative, it becomes positive. And when I square I squared, it changes it back to a negative. So this gives me negative 16 minus 30i. So whenever I see a binomial square, this is what I do. Square the first term, double the product of the two, and square the last term. So I would never show work on a problem like this. And we kind of worked on this a little bit before, so if we had one like this, 3a minus 2b, quantity squared. If we squared the first one, what would it become? 9a squared. Double the product is negative 6ab, double that, negative 12ab, and square the last one, 4b squared. So I don't ever show my work when I have a binomial square. I always just square the first term, double the product of the two terms, and then square the last term. And it's the same thing. That's what happens every time. And we learned that by building our Pascal's triangle. That it would be square the first one, double the product, square the last one.
Okay, so since this is squared, wouldn't it be 1 times 1?
It'd be 1 times 3a squared, which is 9a squared.
Well, but on the triangle, isn't it just the second one down since it's squared?
No, this is the squared.
The first one's just the
That's the 0 power.
That's why I've been doing this. That's why I've been getting all the answers wrong.
You missed that crucial step, huh?
Yep. That's why I'm an idiot. Basically.
Alright.
I agree.
Okay. So that throws back in some of our I.
Gosh, just
And-
getting all the wrong answers. Oh. Here we go.
Okay. So let's look what would happen if we had greater powers. Is this a problem example number? No, I haven't been numbered. Okay. So let's say we had 3i to the 7th times 2 minus 5i to the 3rd plus I squared times 4 minus I.
I'll pass.
No.
You said all pass. That's
All right. What I usually do is I'll simplify any power first. So I to the 7th.
That's negative I.
Negative I.
Oh, wait.
So this becomes 3 times negative I, which
Negative
is
3i.
negative 3i. Okay, I to the 3rd
Oh,
is negative I, so that's negative 5 times negative I, so that makes a plus 5i. I squared,
Negative 1.
negative 1. Okay, so what we did was this step where we simplified I to the 7th. I to the 7th is the same as I cubed. And what is the value of I cubed? Negative I. So this term simplifies to negative 3i.
Well, how do you know if it's the same as I cubed again?
Okay, 4 goes into 7, and what's the remainder? 3. That's why it's I cubed.
Like, why? How do you know what it is?
Okay, so this is the same as I cubed, and I cubed is negative I. Okay, so now once we've simplified everything, we can distribute. So we're going to distribute. Here we're going to change. Here we're going to distribute, and we get this I squared. And what is I squared the same as?
Negative 1.
Negative 1. So it changes that to positive. So it gives me 11 minus 5i.
Okay.
Okay, you try the next one.
Well, that's when these things go downhill.
Where did 11 come from?
You made that.
Oh, does the I go away when you?
Is that I 11?
Mm-hmm.
Yeah, I did the 11. I was putting half quotations around the letter I.
Wait, so when you multiply, when you make I squared -1, does that I go away?
Yep. When I make it negative 1, the I goes away right here. And it becomes negative 1 times negative 15, which makes a positive 15. Are you done with this problem?
I'm not, he's, I'm, okay.
Okay.
So you make it in the third.
Okay, so for doing this one, you have and this goes on to 8. Or does it 8 2
So there's a 3. So it's a
So the remainder is 3.
You gotta bring out
So it's negative I.
Okay.
So you're doing I times negative I.
No, the I goes away, and it's just negative I. Because this, I to the 11 is equivalent to I to the 3rd, which is equivalent to negative I. And that's what you
You have to do another multiplication.
Okay, so you're not like it's not that you're.
And now we have
If
to
there was a
that.
number right there, that's
Yeah.
when you'd be
Yeah.
multiplying. Okay.
7 minus 4. Oh my gosh, Matt. Matt forgot stuff that happened in kindergarten. Long division.
+2, right?
How would you, like, to check your work, how would you plug in an I on here? Would you plug in a 1?
No, there's actually an I button. Where's the I? Right here.
Oh, right there. Maybe we saw that before. Thank you.
It's evil. Like it's evil. Like it's evil.
Your calculator won't do some of the powers of I.
Yeah, I didn't. On the, when you
Okay.
wanted us to go through 10, it didn't work at like, it stopped working at 7.
Okay, yeah.
Wait, we're allowed to use our calculators?
He was just checking.
I'm so stupid. And negative I just equals 1, right? Because negative I is basically, that's basically, negative I is big 1. Equals 1, right? So it's basically just 2 minus 7.
So. Why does I squared still wait? Because there's I squared.
Good question.
4. You don't get rid of it and put 4.
Oh, dang it.
Is there ever divided by the Are we times? X squared, you just need 1 and we're multiplying it.
Wait, how, what? You just do?
Yeah, isn't it weird that it turned into a real number answer when you started with all that complex craziness?
Because -7 and wait, where'd you get 7i to the square?
Negative I times negative 7i squared is positive 7i squared, but I squared I changed and changed. The I squared made that a -7.
Okay.
And -7 plus 12 is 5.
You always drop the I.
Well, these I's canceled out.
No, I'm saying, if you like, if I get the second, you always like take away the I after
Yeah,
you finish.
because I to the second is -1. Okay, yes.
You have like one, let's say like I to the 26. You just count like all the way up to 24, and you know 24 is the one on the bottom, so you count.
Sure.
Okay, that'll count.
All right. Miss Fuller shared with me a way that I helped my. We already did this in regular analytic geometry, but we mixed up the units for you guys, so we did probability first. The thing that they use to help them remember the powers that you guys should not use is I won.
But you don't know which ones are negative.
And the middle ones are negative.
Wait, why shouldn't we use that?
Because you're not using any math to do that.
So it still helps.
But anyway.
It helps a lot, actually.
Yeah, but you can't justify anything. You gotta be able to justify it. You guys need to understand this part. This part's important to y'all.
Well, I've always been
But we need
told.
to know like 10.
Yeah,
No, I've always been.
y'all really get the I won. All right.
No, that actually helps. That was really good.
Yeah, it was good. I liked it. I was like, huh, I've never thought of that.
I won.
All right.
Middles are negatives.
Okay, so let's do some division.
Right?
So, was it in this class that somebody asked why are we bothering to learn conjugates?
No.
Okay, it must have been my 5th
I
period.
mean, I thought that in my head too.
Okay, conjugates are helpful. All right, when we have division and it just ends up looking like a fraction, guys, are we allowed to have radicals in the denominator of a fraction? No. What is I equivalent to?
Negative I.
A radical, the square root of -1. So are we allowed to leave I
No.
in the denominator? No. So we can't have a complex number, we can't have an imaginary number. We have to turn it into a real number in the denominator. So what we always do is multiply the numerator and denominator by the conjugate of the denominator. The conjugate of I is -I. Okay. Have I changed the value of this expression at all if I'm multiplying by -I divided by -I? None. I'm really multiplying by a value of 1, aren't I? So I'm not changing the value of this expression at all. I'm just changing the form. I'm just changing the way it looks. So I'm going to distribute the -1 through the numerator, and I get -4i plus 7i squared. And I'm going to multiply the denominator, I get -I squared. Does everybody follow that? Okay. Well, I squared has a value of -1. So usually I just slash and change, but there's no number here. So I'm going to really think about it as -1 right here. What happens to minus the negative? Becomes a positive. Dividing by 1, does that change anything? Nope. So this simplifies to, let's do real number part first, -7 minus 4i.
Okay, so why is a -1 in front of the... So are you just replacing I for -1?
I'm replacing I squared with -1.
So, and then you don't change the sign because, I mean, you basically did for the 1.
So it's to remain -1 or is it positive now?
Well, it becomes a positive 1 because it's minus a negative. The negative times a negative, and a negative times a negative is a positive.
No, I'm saying you're you're still keeping the 1 in the I squared?
What I did was I completely erased the I squared, and I replaced it with negative 1. And then negative times a negative is a positive 1. And when we divide by positive 1, nothing changes.
But if you divide by a negative, all the signs change.
That's right. That's right. Okay, so when we just have an imaginary number, you can really always just multiply by negative I. Even if it were like 2I, we don't have to multiply by negative 2I. Because if we just multiplied by negative I, won't the imaginary part go away? Okay, so I'm not even going to do one. I'm just showing you that. If you did multiply by negative 2I, it would work. You just have to simplify what you get. Okay, let's look at a complex number divided by a complex number. Okay, so our rule is to multiply the numerator and denominator by the conjugate. What is the conjugate of 2 minus I?
2 plus I.
2 plus I. We're going to start with the denominator so you see why we do this. When we multiply these two complex numbers, we get 4 plus 2I minus 2I minus I squared.
Wait, so you can't multiply by just negative I?
Not when it's, you have to multiply by the conjugate, whatever the conjugate is. Okay, so when I multiplied this denominator by its conjugate, what happens to these two imaginaries in the middle? They cancel each other out. Every time you multiply a complex by its conjugate, those imaginaries are going to cancel out. Okay, and what is the value of I squared, guys? Negative 1. So this is, I can replace that I squared with negative 1. What is 4 minus a negative 1?
Plus 1, 5.
5. Did I eliminate all radicals, no matter what form they were in, from the denominator? Yes. Yes, Chris?
Okay, so you said that you have to multiply by the conjugate.
Yes.
And didn't you say like if it was like 2I, you only have to multiply by the negative I?
Yeah, that'll do it. I mean,
But
if you want to go by the rule that you have to multiply by the conjugate every time, it would be negative 2I. But let me finish this problem then. If I multiply by the negative 2I, I get negative 4I squared over negative 6I minus 2I squared. That cancels, so it becomes 2 minus 6I over 4. Do you see that everything reduces by 2? So you get 1 minus 3I over 2.
If it's just one term, you can...
Right. If it's just an imaginary term, you can multiply by negative I.
Okay.
If it's a complex, you must multiply by its conjugate. Okay, so then I did this and got negative 1 there. So I get 5 plus 5I. Do you see that 5 divides into everything? Yeah. And it's 1 plus I. Now, it doesn't divide nicely all the time. Just some of the time. Okay, we're going to do one more together, and then that'll be it for today. So let's do this one. 5 plus 2I over 3 plus 6I. Do you want to try it?
Yeah.
You try it. And then I'll show you all the work in just a second.
they don't divide like nicely, do you just want to slip it in the
Fractional form?
fraction form?
Mm-hmm.
How did you get 36i squared?
Positive 6i times negative 6i. Huh. 3 goes into all those, doesn't it? Or you could write this as 3/5 minus 8i over 15. Alright, how'd you do?
I actually
Alright,
got
your
that one right,
homework
Sylvie.
is Tuesday night's homework on the calendar. Okay, remember we're still a day behind.
Why'd you do 9 plus 36?
Because
Oh,
I
it's
knew.
I squared. Okay, never mind. I got you.
Okay. And I knew the outer and inner were going to cancel, so I didn't even bother doing it.
Oh, we can
Maybe
have
I got
a
that
test on all of them.
Look at the calendar.
Shut up, Matt.
I give